Okay, here is the first video lecture for my Upward Bound students at West Virginia State University, summer 2015. I've already sent the video lectures to you on memory, and I was hoping that we would be able to meet, but the water shortage is really throwing a curveball for our in-class meetings. So what I've decided to do is to go ahead and finish up the stuff on learning here with these video lectures. You'll need to take notes on these as well. I'll give you an idea, sort of an idea of what you need to write down. You do need to cover the major concepts and the definitions in your notes. I'm going to ask you to submit these notes as well for a grade, probably on Tuesday. I think the first set I was asking you to have those ready Monday. These won't be quite as long as the memory video lectures. We've already covered classical conditioning and we've covered operant or instrumental conditioning. And we did that in class the one day we actually got to meet in class this week. So now we're going to cover cognitive learning and we're going to cover observational learning, the last two of the four major types of learning. So here we go. Again, make sure you are taking good notes on these because I will be taking these up for a grade. Now, the last slide I showed you in class, we were talking, just so you have a frame of reference, we were talking about instrumental or operant conditioning. We talked about shaping and primary reinforcers, secondary reinforcers. That's all review. And then this is our pickup point. Now, cognitive learning, this is learning that occurs through the process of thinking or the process of cognition. This type of learning suggests that we don't have to be sort of classically conditioned. There's not an instinctive process necessarily. And we don't necessarily have to be reinforced or punished to learn. Sometimes we can simply think our way through a problem without punishment or without reinforcement. So, the idea of latent learning, this is still under cognitive learning. Latent learning suggests that learning can be achieved without rewards or punishments, like I just said. Wolfgang Kohler was a German psychologist, and he came up with the idea that this could occur. And the German word he used was Umweg, and you see it in quotations there. Umweg literally translates to roundabout. He suggested that animals and people as well learn sort of in a, quote, roundabout way. I'm going to explain what he meant by that. Essentially, he suggested that we learn sometimes through trial and error, just kind of by thinking our way through a problem. Now, Kohler set up a situation, and I'm not an artist, where he put a chimp, and you can see the chimp, inside of a fence, and he put the banana, which was the desired object for the chimp, outside of the fence. So the chimp's job was to figure out how to get the banana through the fence. And it kind of looks something like this. Again, I'm not an artist, but I'm going to try to get this to where you can kind of see it. You see the chimp, he's in the fence, and the banana is over here on the outside of the fence. So what happened, he put a little opening right here where the chimp could get out. Now, initially, the chimp was trying to work his way through the cage. He was trying to dig under it. He was trying to walk through it. Sooner than later, he figured out, you know what? I can just walk right through this opening and go over here and get the banana. Suggesting that once he obtained the banana, there it is again. Again, I'm not an artist. But once the chimp acquired the banana, mission accomplished. Now, he wasn't punished for this. There was no reinforcement. And there was essentially no instinctive learning that was happening. He just kind of thought his way through the problem. So that's kind of one of the first classic examples of latent learning. Now, Edward Tolman, at the bottom, came up with the idea of cognitive mapping or cognitive maps. Let me give you an idea what that means. He says that we learn sort of by creating these mental representations of things or objects in physical space. Okay, so there's your definition of a cognitive map. Write that down. A cognitive map is a mental representation of objects or things in physical space. Okay, so, and he says that, and I know it says George Washington High School, sorry, but that's the high school I'm going to use because when I first taught this unit, I was teaching this at George Washington High School, but you're going to get the idea. So what I usually do in class is I ask students to sort of pull out a piece of paper And you can do this too. I would challenge and invite you to do this. And maybe, actually, I'm going to make you do this. Put this in your notes. When you submit your notes to me on Tuesday, I'm going to want to see this. And what I'm going to do is I'm going to ask you to construct a map of, let's say, West Virginia State University, because that's where our class is. So you're not going to do George Washington High School, and you're not going to do your high school, wherever that is. I want you to construct a map of West Virginia State University. And I'm not going to give you any rules. You can put your map together however you want to do this. So maybe pause the video and take 5 or 10 minutes. Buildings, parking lots, landmarks, however you want to represent, this space, okay? And I'm going to submit to you that several things are going to happen. So unpause the video when you're done with your map after about 5 or 6 minutes or so, and then we'll resume. Okay, I'm going to assume now that after you've paused, you have your map. What happens is that we tend to represent things that are most familiar to us in the center of our maps. So my guess is that probably a lot of you will put Sullivan Hall pretty close to the middle of your map, because that's the major building or major landmark that you're most closely associated with, because you may not have classes in other buildings. A lot of you probably are not going to put the Davis Fine Arts Building or Wallace Hall or Farrell Hall or Hill Hall or the tennis courts at the center of your map, because you're probably not spending a lot of time there and you may not be familiar with those areas or that area. Probably you're going to have some sort of a roadway. You may have a map from your home to the campus. That's fine as well. You probably are familiar with the student union and the cafeteria. I'm willing to bet that a lot of you have that represented in your map. You probably have a parking lot. Probably the parking lot there at the student union and where Sullivan Hall is would be my guess. So we have a tendency to represent things in physical space in terms of things, especially in terms of things that are important to us. Also, we use this to learn. And the example that I'm going to use here, oops, I went too far, is if you were in your home, it was pitch dark, and I blindfolded you on top of that, and I set you on your front porch, and I said, okay, you can't see anything, but I want you to walk from your front porch to your bedroom. Most of you probably could do that, because in your mind you can represent physical space. You know the layout of your home, and you could probably pretty easily walk blindfolded from your front porch to your bedroom. Now let's say I put you in a different spot. Now I'm going to put you not on your front porch, but I'm going to start you in your kitchen, which may be in a completely different part of your home. And I'm going to ask you to again walk to your bedroom blindfolded. Again, you could probably do it very easily. You're not going to take the same steps that you took the first time from your porch as positive reinforcement would suggest. You take the same exact steps to get the same exact result. Well, no. This time, you're in a different part of your house, so you have to take different steps to get to your bedroom from your kitchen. Okay? So we learn just by thinking things and being able to create mental representations. That's an aspect of cognitive learning. Now, problem-solving approaches. There are 4. We may not get through all 4 of these in the first video. The first problem-solving approach, and you're going to want to have all these in your notes with definitions as well, is called insight learning. The first thing that we talked about with the chimp and the fence represents insight learning. It's almost as if, by definition, with insight learning, that you sort of think your way through a problem to the point where you just kind of come up with it. You come up with an aha moment, if you will. No different for the chimp here. If you remember, it's probably kind of fuzzy, but hopefully you'll get the idea here. Let's put it right there. The chimp eventually figured out that he couldn't vault through the fence or over it. He had to go through the opening to get it. It's almost like he sat there and all of a sudden he had one of these, aha, here's how I do it kind of moments. You've probably had those moments on tests where you're staring at a problem for minutes or maybe longer, and the answer just kind of comes to you out of nowhere. That's insight learning. Now the next type of problem-solving approach, or the next problem-solving approach, is sub-goal analysis. Very simply, by definition, sub-goal analysis involves taking a large task and breaking it down into mini tasks. Okay? Again, taking a large task and breaking it down into mini tasks or smaller tasks. Example, research paper. How many of you have waited till the very last minute, the last night even, to do a term paper. Probably a lot of you. I did the same thing all through college and graduate school. I do not recommend it. It's not a fun way to do a research paper. Now, if I have a big job and I know I have a month to do it, what I might say to myself is, okay, I have 4 weeks to do this. The first week, I'm just going to get my research together. Okay, by the second week, I'm going to have a rough draft done. By the third week, I'm going to have sort of my final draft put together. And by the fourth week, I'm going to have it completely polished and fine-tuned. That way, I'm spreading it out over time and I'm doing a better job with it. A home improvement project may be another example. If your basement floods and you have a big mess, you're not going to be able to clean it all up in one day or one afternoon. You're probably going to have to make little tiny goals. Like maybe, for example, say by the first week I'll get all the water out of the basement. By the second week I'm going to have everything out into the yard, all of my possessions, and figure out what I can keep and what I can't. By the third week I'm going to have someone come in and clean up all the water and clean up all the mold. By the fourth week it'll be ready to get all my stuff back in. So it's something that we all use. And we all problem-solving approach that we all use, depending upon the circumstances of the situation. Algorithms, the third type of problem-solving approach. Simply by definition, an algorithm is using a mathematical formula or equation to arrive at a solution. E equals mc squared. A lot of you have seen that, and probably a lot of you have had to deal with the quadratic formula. So again, just very specific mathematical equations being used to arrive at solutions to problems. Now we're going to discuss heuristics. I'm going to go ahead and call this the end of the first video part here, because I want to come back and we're going to talk about 3 different types of heuristics with the next video lecture. So we'll call that the end of this first part. Thank you.